Hello friends, good afternoon. This is Professor A.K.Chaubey, Professor Chaubey's physics class. I am again here present to discuss with you some more logic gates under the physics made simplest. We have earlier discussed AND gate and OR gate. Now I go to the NOT gate, or this is called inverter. Using NOT gate or inverter means whatever input, output is invert of that, reverse of that. Means if input is A, that is the high, output will be 0. If input is 0, output will be high, A. That is output will, so 1 or whatever, 0, 1 language. If input is 1, output will be 0. If input is 0, output will be 1. So that this circuit, you see that NPN transistor here, Q1 is NPN transistor. This emitter is grounded. This is the base connected to the negative battery for proper biasing. And this is the resistance here. Here A is the input. And this is the positive voltage coming to collector. This is the NPN, so N collector. And through load resistance RL. So when current flows, there will be voltage drop here and potential here will be very small, even less than 1 volt, maybe 0.2, 0.5 like. Because it is highly conducting, the voltage across the transistor collector is almost 0, or very small, 0.2, 0.3. So if I connect an input here, that is say it is high, say 1, then it goes to here, and it is input is high means it is highly biased so that current flows here. Current will flow here in this. The total potential will be here across RL load resistance, and collector will have almost 0 potential. So 0 potential means output 0. So when A is 1 or A is high, output will be low or 0. If there is no input, this is not properly biased, not highly biased, so that current will not flow. Current will not flow, the total voltage of the battery will come here. So this will be high, means 1 state. When this is 0, this becomes 1. When this is 1, this becomes 0. Because 1 means high voltage, 5 volts current flows and no potential drop here. So Y becomes 0. So this is the inverter circuit, means whatever input, output is invert of that, means opposite of that. And the truth table will be like this. When A is 0 means low state, Y output will be high state 1. When A is 1 high state, output will be 0. Because it is conducting, so no voltage here, so 0. So this is the truth table of NOT gate. This is also called inverter. Earlier we have discussed AND gate, and we remember now I give the representation. AND gate is represented by this diagram. This type of diagram where you find in the book, this A and B, there are 2 inputs, and the logic you know is that when A and B are present, output Y will be there. That was AND, but we represent AND gate by this symbol. And this is the OR gate, that OR logic, the symbol is here, and you know this truth table, when A or B or both are present, output will be there. When A0, B0, both 0, nothing. A or B or both are high, output will be there. If they are low, output will be low, 0. So A or B or both. So this is the OR logic gate. This is AND means A and B are present. Here A or B or both present, output will be there, Y will be there. So this is the presentation of the OR logic gate. And this is the inverter, or you have NOT gate. No, NOT means obviously nothing, or inverter. And this, you know, is the symbol representation of input, or that is the NOT gate. NOT gate, only one input there. Here there can be 2 or more than 2, 3, 4, depends upon how many inputs you have. So truth table will be accordingly different. When there are 3 inputs, so we will have A, B, C, we can make truth table. But this is the representation of input here and output here. A is here, the Y is A inverse, means inverse of A. If A is 1, this is 0. If A is 0, this is 1. So this is the representation of NOT gate, that is the negative gate. Okay? So this is about the NOT gate and the representation of AND gate and the OR gate, etc. Now we go further, some more discussion, that we want to have some more discussion, and discussion will be say, or what I say, some further logic gates, and further logic gates means I want to combine this, combination of basic logic gates. I go now to combination. So you have AND gate, you have NOT, inverter. Well, we couple these two, we make, say, couple of these two means that is called NAND gate. N-A-N-D. NAND gate means a combination of and NOT. Means we combine two gates. Which two gates? AND and NOT. That means we have here representation of a AND gate. It should look like AND. That is a two input A and B. This is the AND logic. Combined with this, we combine a NOT gate. That is the, you have NOT. So A and B, and here you have, say, output will be Y, that is written as A and B. This is output. A and B. And now here output will be Y here. This output will be invert of this. So A and B invert. Y will be A and B invert. And the logic truth table will be truth table. Truth table will be, say, where input, say input I have and output I have. So this is a output, and output we divide here like this, and here we have, say, input, two inputs, say that A and B. These are two inputs, and here we get AND logic. AND. So the logic truth table is that 0, 0, both are 0, 0, and this is also 0, and this is 1, this is 0, this is 0, this is 0, this is 1, this is 0. Both A and B are present, then this is 1. So this is the AND gate. And now AND gate we have invert of this, it means reverse. So here what will be the output? This is the output is NAND gate. NAND output, NAND gate, Y output of here. This is also Y output. What will be inverse of this means 1, 1, 1 and 0. So that is the, and this is represented like this, or you can represent this by, say, two input A and B, and just here you put like this. Then this is input, and this is now NAND. Means and this symbol for here this, invert. So this is NAND, A, B, and output is here Y. And we know this is the truth table of first AND and then inverse NAND. So NAND gate is the combination of AND and NOT. Wherever we want inverse of this AND, we use this type of the gate. This is called NAND gate. And we can have also another gate combination of, say, let us see, NAND and OR. If we combine if we combine NOT and NOR, OR, we combine, say, we have NOR gate. NOR means combination of NOT, combination of, first we write OR and NOT. We combine OR with the NOT, we will get NOR gate. And here representation is that this is the OR gate. Here A and B input, and here we have output, and this output is here. What output is here? A plus B, write this here. My prime output here is A plus B, write me like that. That is the A or B. So, and then this is connected with the NOT. So NOT gate here, we connect this with the NOT. So this means here Y will be A plus B inverse. A or B inverse of A or B. Means if A or B or both are present, we get A plus B, output is there. That is the logic. And invert of this will be A plus B inverse. So this you can write you can represent this both combined together. You can represent a NOR gate simply by a symbol like this and here circuit. This combined here. So this is the NOR. NOR means OR combined with NOT. Invert of OR. That is the invert of OR is NOR. So these are the logic circuits which are based, they operate, they work under some logic, and logic is this. And you see the truth table of this will be, you can make truth table of this. Truth table. What is the truth table? That is input and output. Input and this is output. This is output. So what will be the A and B here? A input and B. And what we have here, output is say OR first OR, that is say OR and then NOR. So what is the input A and B for the OR? This is 0, this is 0, this is 0. And invert of this will be 1. No. And this is a 1, this is a 0. What will be output? This will be 1. And this will be 0. If this is 0, this is 1, this will be 1, and this will be 0. And this is 1, and this is 1. This is 1, and this is 0. So only for one logic it is output is there, other logic output is 0. So this is the combination of NOT with the OR, and it gives inverse of A or B, that A plus B. A or, this is written as A or B. And here we write A dot B, this is called A and B. This is the AND logic, this is the OR logic, output representation. So this is the NOR. This way we have AND gate, OR gate, NOT gate, NAND gate, and NOR gate. These all gates, logic gate circuits are used in the electronic circuits. They are applied in the electronics using transistor, etc. We can design them. And we can say, you see, I can prove that NAND gate NAND gate is fundamental. NAND gate is fundamental. What is the meaning? We can get all the gates, from NAND. That is important. We can get all the gates from NAND. I will show you this, that how we can get all the gates from NAND. You can see that. See, inverter, I can make a table and you can see that, yes, I can get all the gates from the NAND. This is the table here, and table is like this. This is here, say inverter, I write here. Inverter. What is inverter? NOT gate. So inverter is NOT gate. And here I represent this as the NOT gate, means I have here one input and this is the representation. Here is the output Y and this is A. So this is the inverter. And inverter means Y is A inverse. And then I go to the how to get inverter from NAND gate. We see NAND gate is the, what you know? NAND gate is A and B, two inputs, and here we have NOT connector. So this is the A and B, and this is the, if A and B is Y is the output, then this is the Y inverse. Here is the Y is the output of this, then this invert Y inverse. Now you can see that how we get from this NAND gate, we get inverter. What we do? We join this B. We connect A and B together, means we make one input. Now what will happen? From this only one input, we will have inverter NOT gate, means when only one input is there, there will be no output here because it is AND gate, and here it will be output here, inverse of this. If A is there, nothing will be there, inverse of this. Because A is coming here, there is the AND gate, means there is only one input. AND gate, one input, nothing will be there. Then here invert of this. Like that, invert of this. So this is the, if you short the two inputs, make one input, this becomes inverter, AND gate. Because A is there, some pulse is there, it will not be coming here. Because A and B, this is connected. So at both we have A and both pulses are present. So here we have output, but this inverter, this NAND gate will invert. So no output. Means A plus A, both are A. This is also A, one input. Here we get output here, Y. And then here we get Y inverse, because this inverter is there. So NAND gate reduces to inverter when we join this two input like one. Then we get inverter from the NAND. Next thing is AND. How we get AND is, AND is the two input. B and A. Here is the output, Y. Now what we do? We write A and B, output Y. We now use, say, here one NAND gate. We have NAND gate. NAND gate is here, this is the NAND gate, A and B, and this is the negative, invert. So this invert. NAND gate, one NAND gate connected with one gate, which is the inverter, this inverter, where we have shortened the two inputs like this. And then here, this is a NAND gate, then this is the inverter. So this inverter will invert the NAND output. NAND output means when A and B both are there, this will be 0. And when this will invert means there will be output here. So whatever here, we will get output A and B is NAND. So A and B, when A and B are there, no output. But when no output, inverter will have output here. So when this is 1, this is 1, this will be here, no, and then no means A here. Output of Y is A and B. So this one NAND gate and one NOT gate combined together will give you AND gate. So NAND gate reduces to AND gate. We combine two gates, one NAND and one NOT, and we get AND gate. Similarly, we can get OR gate using NAND gate, fundamental NAND gate, and OR gate is represented by this symbol A and B, and here is the Y. When A or B or both are there, Y will be there. So that is Y is A or B, A plus B. And now what we do? We take two inverters. That is, say, we have this connected here, and we have one input here, A. This is the inverter. From this we have made already here. So we take this gate, means inverter, and we take another inverter from the NAND gate. NAND gate, we have another inverter, means here this is also shortened, and here we have this, and then we combine this with the AND gate, with the NAND gate here, because we are converting NAND gate, we are taking NAND gate, and we want to show that NAND gate gives all the gates. So this is the Y. These two NOT inverters means A and A here we will have nothing, no. And then this is NAND gate, means we will have here something. So this gives OR gate, means when A and B both are present, we are getting here logic or logic. Or if A or A, this is there, because this is a NOT gate. This will give, NOT gate will give pulse here, but A is here, it will not be here. So when A is here, it will not be here. When A is not there, but A is here, well, this will invert. Because here nothing will be there, then this will invert, because these are both NOT gate. So this is present, here nothing will be there. This is present, here nothing will be there. So when nothing is there, no output here. When A is there, this is not there, so A is there, here we will get output, here we will get. So there is one output, and this is NAND gate. One output we will have output here. So this combination of two NOT and one NAND will give you OR gate. So you can see that NAND gate is more fundamental gate, because NAND gate reduces the combination of NAND gate. This is NAND gate, this is NAND gate. This is from NAND gate we have inverter, so this is inverter using NAND gate. Two inverters connected here, and this NAND gate. This gives here OR gate. So like this we can see that NAND gate is more fundamental, because this can provide you all the gates, AND gate, NOT gate and OR gate. So friends, this is all about gates, and now on the next one I will solve some problem of some short answer questions or multiple choice questions of the gates and also transistor and diode. So I will take all the problems of PN junction, diode, transistor and the logic gates together, and maybe next lecture I will combine all this logic gates and the transistor problems, numericals or the objective type questions. So friends, I will stop here. Thank you very much.